Hey, what's up guys? This is Akshay from AS Learning, and this tutorial is the second one in our gensim playlist, and this is regarding topic modeling using LDA. So let's get started. Before starting with the video, it would be really helpful if you would subscribe my channel. It would really help my channel grow. So let's get started. So the main agenda of this video is to build a topic modeling by using LDA with the help of gensim. Okay, so first we will be importing our gensim library. Okay, so this is my corpus. So I would be detecting out the important topics which have been spoken in this corpus. This is a very small corpus. Okay, so by the way, what is a corpus? So corpus is a collection of documents. And what is documents? Document is nothing but a normal text. So understand in this way that if you have some amount of text, so that will come into documents, and collection of documents will be your corpus. Okay, and my main agenda here is to come up with topics which are being spoken in that corpus. That is called as topic modeling or topic detection. Okay, so this is a very basic topic modeling by using LDA. So we won't be going into vectorizing and all. We would be using a bag of words itself. Okay, so this is my corpus, and what I've done here is I have imported sentence tokenizer from NLTK. So NLTK is a library for NLP operations. NLTK stands for Natural Language Toolkit, and we have imported sentence tokenizer for breaking our corpus into different sentences. Okay, so okay, what is the error here? Okay, let me try once again. Yeah, so I have broken my corpus into sentences, and here you can see the list of sentences. So we have around 1 2 3 1 2 3 4 5 6 7. So this corpus contains 7 sentences, and my agenda here is to build a topic detection model on these 7 sentences. Okay, so the first step when it comes to topic detection is it is always nice if you remove words like which are occurring a lot but they are not contributing enough context and meaning to the topics. Words like the, of, so mainly prepositions and articles. So these words are repeated a lot, but they don't inherit to the topic detection. That is, those words don't contribute to the main parent topic. Okay, so it is always nice if you remove these words, and removing these words is called as stop word removal. Okay, so we will be doing stop word removal on the words here, but before that what we will be doing is we will break down these sentences into tokens. So what is tokens? Just understand tokens as breaking of the sentence into smaller chunks. Okay, so I have considered here tokens as my word tokens. So here for example, in this sentence, in will be my first token, terms will be my second token. Sorry, so I have been using here gensim utils.simple preprocess. So what does this function do? As you can see, this function is taking all the sentences as input, and it is performing simple pre-processing of gensim on it. So here we have the parameter of DAC. So what is DAC? So DAC stands for deaccent. So in some of the languages like German and all, we have accentified words, like we see commas and all in in front of those words, in above those characters. So those characters represent the accent of that word, right? So by keeping d accent true, I will be removing all such characters from my tokens. Okay, and I have kept my minimum length as 3. So any word or any token which is less than 3 will get discarded. Okay, so here as you can see, my first token, that is in, should get discarded because I have kept here minimum length as 3. So this is my list of pre-processed data. We'll try to see this, how it appears. Yeah, so as you can see, my first sentence, as we have kept here minimum length is 3, my first token that was in got discarded, off got discarded. Okay, so this is how my corpus appears after doing a simple pre-process of gensim. After that, what I will be doing is I will try to create bigrams by using collocation technique of gensim. So what is collocation? So in simple bigrams of NLTK, what happens is if we have a sentence like Akshay is teaching NLTK, so it would create bigrams like Akshay is teaching, then teaching NLTK, right? So it will consider all the words and it will create the pair of all the words with its predecessor and its successor. But what happens in collocation is it try to make sense whether the word in the predecessor and the successor does it have sense. So how does it comes with the sense? It comes with the sense with the count of those words, the occurrence of those words. If those two words are occurring a lot, they get concatenated in the form of a bigram, and if not, then those words are kept in the corpus as single word itself. Okay, so that is my task of bigrams. So I'll give you one example now. For in this corpus, as the corpus is very small, so we won't find frequently occurring bigram words, so most of the words would be kept single only. But if I have a corpus in which there's a lot of occurrence of two words like sunny day, sunny day. So what happens is, if in my corpus sunny day is occurring a lot of time together, it would concatenate into sunny underscore day, and that would be treated as my bigram. Okay, so the next step here is lemmatizing and stop word removal. So we have already removed some of the words by using minimum length, but if you want to remove unwanted other prepositions and unwanted other words which don't contribute a lot to the topic, so we can use stop words here. So here I've simply imported the stop words from nltk.corpus and I'm using the lemmatized function of gensim utils. Okay, I've created a set of English language stop words and here I've written a function. So what I'm doing in this function is I am at first removing the stop words here in my first statement. In second statement, I'm applying the bigrams, okay, on that corpus, and in third statement I'm lemmatizing it. Okay, along with lemmatizing, I'm only picking the proper nouns here. Okay, because NN stands for proper noun and I've kept my minimum length as 5. Okay, so what is lemmatization? Lemmatization stands for bringing the word to its dictionary form. Okay, so if you have words like playing, so playing would get lemmatized to its dictionary form as play. Okay, so we so what are the benefits of lemmatization? What happens is playing, played, player, they all are giving us the hint of play, right? So play is more important there. So that is why we try to focus more on play, and that is why we prefer lemmatizing it. Okay, so I've created a function here and then I'm calling out this function. Okay, now my corpus is ready. Now what I have to do is I will create a dictionary. I'll be importing your LDA because I'm using your LDA. You can use other models as well. We have LSI, we have RP, we have HDP. So there are many models, but LDA is very popular and it gives really good results. So of my train test, I'll show you the train test, how it appears. Yeah, this is how my train test appears here. Okay, I'll be creating dictionary. What does dictionary do? In a normal dictionary, we have entry for each word and there's a unique entry, right? So dictionary is created for unique entries. Okay, let me print it. Yeah, so I have a dictionary of 24 unique tokens. So in my corpus, there are 24 unique tokens. Okay, and from this dictionary, I'll be creating a corpus. And I have used your bag of words, talk to bag of words method for creating a corpus because my model won't understand string, right? It only understand numbers. So how does my corpus appears? I think I printed corpus here below. Yeah. So this is how my corpus appears. Now, what are these numbers exactly? Now try to understand here. I have 24 unique tokens, right? So each word has been assigned a unique ID. 0, 1, 2. As you can see, this number is up till 23. 0 to 23. And in that typical sentence, what is the occurrence of that word? How many times that word is occurring? That is indicated by the second number. So token 0 is appearing one time, token 1 is appearing one time. Here you will have entries here, token 5 is appearing two times in this way, right? Now this corpus will go input to my LDA model. I am keeping my parameter number of topic as 3 and I've importing, sorry, I'm also passing my dictionary to the parameter of ID2 words. I'll keep here number of topics less because my corpus is very small. And let's see what are the topics detected. So it has detected. So in this two, so what happens is what does LDA does is it tried to map the entire corpus into two topics, right? And here in these two topics of 0 and 1, it has picked up some most contributing words, and these are the probabilities which represent the contribution of that word towards that topic. Okay, so let's see, we have here model, then we also have seller. So let's check our corpus once, and do we really have model in it? Yeah, as you can see, a models. Then there's only one occurrence of model, I guess, but I think it was contributing a lot. And even it makes sense, like this is a Ford. This topic seems regarding any car model. It makes sense. And if a model Ford tutor standard, see here, there's one more time model is appearing here. Standard, yeah. So it makes sense. The contributing words make sense, and that is how my entire corpus is being divided into two topics. Okay. So if you want to see this into a graphical form, so you can import pyldaviz.gensim, enable the notebook, and you can have an entire analysis of this LDA topic detection in the form of a beautiful graph. Yeah, so as you can see, we had two topics here, which word is contributing most to the topic, right? Then you can select your your relevance parameter and play with the words. Okay, yeah. So that's it, guys. This was it with the video. If you like this video, give it a thumbs up and subscribe to my channel AS Learning for more such amazing content.